All right.
I have to get back where we were.
All right. So what is the surface used for in Civil 3D? Any idea? Start throwing things out.
Profile, elevations,
Profile?
contours,
Contours?
pipe networks.
Pipe networks? Good answer. Basically everything, right?
Yeah.
all the data that we provide in Civil 3D uses a surface in one way or another. Even your pipe networks, right? Every pipe network that's in the drawing is connected to your surface. Any pipe that you generate from that pipe network uses rules that basically say, hey, use minimum 3 feet of cover to set the pipe. All right, so that's how important surfaces are. Basically everything in our drawing is somehow related to the surface. So having the right surface and the right data in our surface is pretty paramount.
And then the other thing to keep in mind is when you're dealing with surfaces, remember we were talked about accuracy in the beginning. And so a lot of times we'll do
Really?
Volume calcs for earthwork off the surface. Okay, if the surface is plus or minus 6 inches, okay, and you're doing something over 25 acres, I've seen that go down to 0.01 of a cubic yard. That accuracy isn't there. You're good if it's about 100 yards, okay? So, again, keep in mind the accuracy of the data that you're using, okay? If it's plus or minus a tenth, because that's all you're using, okay, then remember, if you need to set a trench down at 3 feet, okay, it is plus or minus a tenth, okay? So, again, our survey crews take care of that out in the field, okay, but not always, okay? So
we said existing ground profile above proposed trench alignment. Typically, we don't use that surface to call set out elevations, right? We're not really designing off of that. The level of accuracy is pretty low because usually that comes from our aerial topography, right? Anytime we want to join or match existing planimetrics, like curb and gutter, retaining walls, settings where we set elevations to the 100th, the required level of accuracy on that is very high. So what type of data would we want to use on that application? Survey data. What type of survey data? Total station, right? That would obviously be the best. Sometimes we're only going to have GPS. Then what do you do?
plus or minus.
So there's a couple things that we need to do. A, discuss it with your project manager and also the surveyor. See how accurate their GPS was that day. How does it compare to other days that they were out on the site? Are you seeing some variation in your survey data? Analyze it a little bit. The other thing too is make sure to note on your plan to field verify all your join elevations, right? Cover yourself a little bit. Build some verbiage in there to kind of let you off the hook. Put it on the surveyor, put it on the contractor. So field verify on any join and match elevation. Pipe networks we already talked about. Typically, those are kind of plus or minus anyway. So do we care whether or not it's 0.2 feet off? Sometimes not, but you do need to be aware of, hey, your pipe networks may be 0.2 off real world application, but it's all relative to your finished surface. So typically we're okay. Naming guidelines real quick. File names, EXTO, EXTO-C3. The C3 file is the one that has your surface tins in. PRTO, and then PRTO-C3 that contains your proposed surface tins.
And I have a request. Please do not archive the surface drawing, okay? It breaks every single shortcut set from it.
Surface names. So this is a little different. This is some new information. No longer call it EG or EXTO. Let's start giving it a little bit more information. So basically EX, and then what data did this surface derive from? If it's the aerial topography, EX-aerial, EX Lidar, EX survey, and EX composite or comp, which we'll get into at the end of the course. For proposed, hey, let's go PR and do the same thing. Instead of part there, where did the surface come from? How did you build it? So did it come from a corridor? Should be PR corridor, and then whatever corridor your name is, road A or whatever it is. Give some helpful insight on where that surface came from.
Hand-drawn contours.
Grading object, grading group. Where did it come from? The next thing, anytime you create a surface, it asks you. There's this big box for description. There are two things that are required to be in that box: the date that it was created, and your name, the name of the creator. Just so if we ever have any questions regarding back to the surface, we know who to contact. All right. So that also, take ownership of your work here, guys. You guys do good work. Put your name on it. Volume surfaces. Two naming conventions there. There are two main types of volume surfaces, grid and 10. 99% of the time, we are going to use a 10 volume surface. Feature lines. Where do feature lines get drawn? Where do they appear in our prospector? Anyone? Site. It's right there, right? All right, so feature lines belong to a site. I can't tell you the number of drawings that I've opened that have 10 different sites. None of them are named. They're just site 1 through site 10. So let's start naming our sites. Anytime you draw a feature line, go through and name the site. Give it a description of what it is.
Fill out the description box in the site. There's a description box that says, you know, what the site is all about.
You also need to give your feature lines names. Anytime you create a feature line, it will generate a feature line, but it won't give it a name. You need to fill in the name. Give us an idea of what it is. Is it TC? Is it a flow line? And also you might need to be a little bit more descriptive in your name, like TC North, if it's the north curb or whatnot. By looking at the name, I should know where that feature line is in the drawing. These things are all part of my surface, so I need to know where they're located, what they are, and what they are in my surface, what they're supposed to represent.
So one of the other things that we rely on is data shortcuts. So in here, we've kind of shown an example of where you would find the data shortcut. It's down in that lower portion of the prospector, okay? But that data shortcut is used from the C3 drawing for surface, if you will, and then used in a sheet file, is used in the EXTO to make the file lighter, okay? So the actual contours don't have to reside there, okay? So if we keep the file sizes small, when you're referencing all of these files into each other, okay, they'll move faster. So you're not referencing the C3 file, okay? You're only referencing the XTO, or the light version of the file, okay? That way, you keep the file size small, it'll keep the drawing moving faster. There's nothing that slows a drawing down faster than trying to reference a drawing that's 25 megabytes, okay? It'll take forever to open, right? It would be much faster if it were only 1 megabyte or 2 megabytes, okay? So we keep the file sizes down, and then you can always reference that surface or other object, okay, by having no display. We have a no display style. Use them, please. Okay, go ahead.
All right, AutoCAD time.
Yep.
Quick question.
Yes.
Feature lines, so the sites, you have different sites obviously, so the feature lines don't interact with each other. Go and give me an example. I can't recall, like, why would you have like multiple different sites in a drawing?
Good question. One of the most common cases that I've used that for is, some of you might balk at this, but a lot of times I will actually draw cul-de-sacs as feature lines rather than part of my corridor. And as a part of any corridor, you should have a finish surface and also a datum, right? Which is basically what your rough grade situation is. So a lot of times when you develop feature lines for, let's say, top of curb, FS, you also kind of want to develop that same feature line, but at your datum level. So it's the same feature line on top of each other, but let's say this datum one is 2 feet below. You can't have crossing feature lines if they're on the same site. They will interact with each other, they will change, it will be very goofy. So if you have a feature line here and a feature line here, this one will actually dip down and touch this one in terms of your elevation. So it will go in and adjust the elevations of your feature line if they cross while on the same site. So yeah, if you have crossing feature lines or overlapping feature lines, they need to be on different sites. Otherwise, they will change elevations.
So I have to do a little bit of update only because I was going to go to my machine, but couldn't get a license. Hopefully it's just an error problem. Where was I going? 94, 304.
So the question is, how come Mark's files are so massive?
Why are they
I'll let
so?
him answer that one. How about that?
Why are they so massive? Usually I'm using either a ground-based Lidar point cloud, or I'm using the highest density of points I can get. Okay, so typically the C3 file will be very massive. I'm using, a lot of times I'm using pipe networks in a UT file that's a C3. And so I'll have all those pipe networks in there. But a lot of times I go overboard on a pipe network. Surprise, surprise. And I'll do the entire network because a lot of times my design is going to shift sides of the street, okay, or go to a point at which I don't have the network completely drawn. And so I'll usually model enough of it to be there. I don't model a pipe network as level based on the pothole elevation that just so happens to be there. I'll model it based on its true slope, okay, based on hopefully multiple pothole information, and then be able to model that information so that as I cross the line, if I move where I cross that line, that data updates.
Right.
So a lot of times my files are large because of that.
I was doing that Melrose project that was, I got everything in one file.
So especially with proposed topography, some of the files can get rather large when you start talking about basing your proposed surface off of a corridor, and then you start adding grading groups that then target certain, surfaces. Proposed grading can be quite intensive and require quite a bit of computing power. One of the things that you hopefully are noticing is that your files are becoming faster. Anybody experience that?
Yeah.
Yeah, all right, handful of hands, that's what I like to see. So part of that, if you recall, a couple of weeks ago, I sent out an email regarding file degradation, especially using 2013 software. Who's using 2013? Oh, I know there's
more than that.
You guys, I can see the licensed server. I know exactly who's on what version. Typically on a day, there's still about 10 people every day still on 2013. You guys are corrupting your files. Hope you realize that. What I'm actually going through is I'm going through every folder on the N drive and fixing all your files, all your AutoCAD files. So right now I'm about halfway down through the N drive. So please stop using 13. Otherwise, you will undo all the work that I'm doing. So I'm about at, I think 153 is the job number. So if your job number is above 153, it has not been fixed yet, but that will be happening in the next week or two. So hopefully everyone will be able to start raising their hand of, yeah, my file's working a lot faster. It's opening faster. It's saving faster. So please be aware of that. Don't use 13. The only justified use of 13, all right? The very only one is if you're updating NV5 pipe labels, pipe network labels, right? That's the only reason to use 13. I cannot get that functionality to work in 16 for one reason or another, which is fine because the software now has a built-in feature for the label crossing pipe networks in profile. So we're going to use that functionality in any new project. But again, only reason to have 13 open is to update those old school pipe network labels, which are actually profile view labels. Any other questions while Mark's getting AutoCAD kind of set up?
Mm-hmm.
Nothing, huh?
Nothing? All right, well, I'm going to actually insert a drawing from the past, and I'm inserting it in a new file. Why? Anybody?
You want to copy of it there?
No.
No.
This should be a part of
This should be normal.
This should be a part of everybody's workflow. Anytime you receive a file that originated outside of the office, this is the protocol that needs to happen. Can't tell you the number of times that I'm asked to go to somebody's computer because the file's not working. First question I ask is, did this file start here? And then typically it wasn't. And then we introduce a whole slew of issues. So like one day I got an IM of, hey, when I create a dimension, it comes exploded. Every dimension I create is exploded. Well, that's an AutoCAD variable that's saved in the file. So whatever company, whatever software created this file, that's how that variable was saved. So you're introducing hundreds of AutoCAD variables that are unknown of how they were set and how it's going to interact in your drawing. So what you want to do is you want to start a new drawing from our template and insert that file in. That way you're in a very controlled environment. All your AutoCAD variables are set. Your zone is going to be set to default zone 6. There's a host of things that are set for you. And you also get all your Civil 3D styles, right? So you be sure.
Speaking of which, your machine isn't set up right. So.
My machine is? Yeah, it is.
No, it isn't. Watch.
Well, it's set to the queue problem.
Okay, well, find it on the queue. Where was it again?
Civil, it's 3D 2016. Templates.
Yeah, it didn't point there directly. So you start an EXTO C3 file, okay? You open that file, okay? First thing I do is erase this nice, beautiful looking block, but and much to his chagrin. Then the next thing I do is I actually insert the file that I want to create the surface from, and which is the aerial tin that comes from the aerial photogrammetrist. Why do I do that? Anybody?
Anyone?
I'm getting a lot of blank stares.
Well, you just told us.
I did tell you.
Because of all the crap it comes in with, it's not one of our drawings.
No, it's that it doesn't have any of the styles or any of the base information that you need to create the C3 file with. Okay? So always insert and explode that drawing.
The only time where explode is a valuable command, right?
Right. Please don't do it on a regular basis.
It's not. If it gets misused, I will undefine it. You can actually undefine commands in AutoCAD.
Yeah. We're not going to tell you how to do that. Come on. It takes too many clicks to get where you need to go on this drive.
I want to go to C drive. Go ahead. Or did you copy it?
I copied it. So I'm actually inserting this one, and there's a couple people that I'll actually might actually know what it is. Come on. Standards violation. Oh, wow. Imagine that. So when we get something from a photogrammetrist, okay, in a break line file, it's going to look like this. But I don't want to use all of this, so I'm going to erase half of it. Bad for me, but. Okay, so I'm going to make a tin of just this. Okay, I want to see what it's going to look like just based on this. So I'm going to create a surface. So again, what we've talked about today is I want to create a surface. What am I going to say it is? Okay.
What's the name of the surface?
Yes, aerial.
Okay.
Good.
Good. At least something sunk in.
Blake was the first to answer, and he doesn't
Well,
even use
what?
AutoCAD. Come on, guys.
Surface one.
Surface one.
Get that man a candy bar.
Okay, I'd expect that. What else is supposed to go in there? Today's date.
Who done it?
Who done it?
Right. So what's today anyway? The 30th? And initials are okay. You don't have to type in your full name if you feel like not typing.
We'll hunt you down either way.
Right. Either way. So again, you're putting that there. Where does this default go to? It goes to the surface named layer of C3. It'll only do that if you start with the template. Okay? So, hush you. All right, so again, once we've made that file, then we can ask for definitions, and we can ask for, we're going to add a bunch of break lines. Okay, how do I get the break lines? Anybody?
Survey figures?
Could be. But in this case,
In this case,
Select them.
you select them. What's the fastest way to select them? Huh? No. It's quick select.
That's what I said.
I thought I heard view select.
You select.
Look, you select right there.
Okay, whatever.
Take that off.
No, I need some wax removed. So I'm going to do that, and I'm going to do it from a layer because I happen to know which layer it is, and this one isn't. This one is on topo break line. So this.
Does that come from the
You
aerial?
know, just type ISO a layer and then select it.
Right, you can do that too.
Yeah.
Either way.
Yeah, that's-
So it selects them all, and then you go in here and say add.
Yep.
Okay.
VK1.
Cute.
I hope not.
Aerial. Okay. Standard. Weeding factors. What does it say in your? Oh, we didn't give a handout, did we? So 2 supplementing factors, 15.2, 10.2.
Everybody understand weeding and supplementing factors?
What does that mean?
No. All right. So using the template, these are going to be your default values. All right. Another reason to use the template. The standard out of the box AutoCAD file has much higher values set.
I think it
So-
says 102.
Yeah, so your weeding factors is it's going to ignore any data that's closer than 2 feet from the last known point. All right, so we're building a pretty specific, pretty tight surface by keeping it at 2 feet. So that's basically every 2 feet, if there's information, it's going to use it. Same with your angle. If there's a difference in the angle between this vertex and this next one, that 0.2 is what's going to be used. Supplementing is the reverse of weeding. It's going to add data along that line. So how often do we want to take a sample along our break line? So this says every 10 feet, right? So every 10 feet along the break line, it's basically going to put a node to use on your surface. So we're building, with these factors, we're building a very detailed surface, all right?
But we're not building a surface that has a point every 100th foot, which some of these break lines can have, okay? So just keep that in mind. Now that we've added that, I should have a surface, okay? Notice that just using the break lines, I got pretty good, surface boundary utilization. There's a little bit of error in there, but I can add a boundary and add that in. But to get these points, you do the same thing. Do a quick select. And I go get points. And we go layer. DTM. Okay, there's 115 items. And then add that as drawing objects. Points. Here's your description again.
A lot of times in the description, I'll actually add the layer that it's on too, just to kind of give as much information as possible. You may also find that it's helpful to add the date, especially when you're talking proposed topography, because your proposed topography changes a lot. So having a date gives you an idea of when the last surface modification happened from your polylines.
These are points. However, in some areas, they are blocks. Okay?
So be aware of that. Good question.
Why isn't it picking up?
So if there were blocks you explode them, it's going to be.
Don't explode.
There we go.
Pick it. So under drawing objects there, there's a pull down where you can select points. You can also select blocks. I think there's 6 different items or categories of objects that you can add as a drawing object.
Was it not exploded when you inserted the drawing initially?
No.
Okay.
So when you insert a drawing into another drawing,
It becomes
that
a block.
drawing is a block.
Right.
All right, you have to explode it once for all that line work to become active. Still has all the blocks that were originally in that drawing
Okay.
as unexploded blocks.
So even when you selected explode on
Yeah,
that
it
insert.
doesn't.
Correct, correct. And the safe way to do that, I don't know if you caught on to what Mark did when he actually went to insert the block. There's a button or a checkbox on the lower left to actually say explode
Yeah,
when you insert it. Just be
That's what I was asking.
Yeah.
Be very careful doing that because AutoCAD will remember that setting
Oh,
next
yes.
time you go to insert a block. All right, so just be aware of that. Sometimes it's better to just insert it and then select it and explode
Okay.
it, just so you're not changing that default value.
Remember I said you'd get errors? Okay, these are the kind of errors. It says it's a duplicate point, and so it's actually ignored the duplicate, okay? If you hit zoom to, it'll actually zoom to the point that is in question, okay? So it's in the center of the screen, basically. It's right in there. So there's actually a point and a break line. So it's using the one that was added first, okay? It's ignoring the duplicate. Duplicates are okay because it's ignoring them. It's when you have a difference of elevation because the duplicate wasn't the same elevation as what was used, okay? So again, if you're using contours, you'll get a different elevation if in fact they've smoothed the contour out, okay? So we can add a boundary to this, but I'm running out of time.
So would we need to add any other additional feature lines to this surface?
You might want to put curb tops in, gutters.
Got those.
Got those, right? We can tell by the contours that were generated that you're seeing the,
Well, you can't.
The curve, right?
How many lines have you got there? 2?
Well,
So-
this is a driveway, actually.
so the one thing to kind of look at that is to turn on your triangles, your surface 10 triangles. So Mark, can you show them how to do that real quick?
Okay, I'm going to go to Surface Properties, and I'm going to say, okay, I'm going to go to existing triangles. Say, there you go.
All right, so that shows you how this surface is actually being generated, what it's interpolating between which points and what it actually looks like. So as you can kind of see in some of this area here, we may not actually want triangulation to happen in that area, right? So in that area, we may want to edit the surface.
And just keep it down, keep it down to the data that is actually there.
So how would we edit this surface real quick? Delete triangles, right? So if we go up to the menu bar, in Civil 3D, there's always like 3 or 4 ways to access the same command, right? I'm a menu guy, so very top menu ribbon. I'll go to surfaces, edit surface, and then delete surface 10, or delete line.
Okay, but the fastest way to do this is just draw a boundary and trim it down with a boundary. Okay, it's faster. You don't have to go in and then select every single triangle. And what if you miss one? Okay, then you have to go back in and do that again. So doing this with a quick boundary is very easy. You just go ahead and add a polyline. And I've got to make sure that I'm not picking points, because that's...
See, sometimes it's quite useful, just 3DO, just to look at it on a 3D board, to...
Yeah.
A better impression of what's actually...
Let me draw the boundary real quick, and then
I
I'll
would
do that.
definitely recommend looking at the 3D orbit of any surface you create.
Yeah.
One caveat, make sure you save first.
Right.
When Civil 3D first came out, whoever used Civil 3D 2009, anytime you did a 3D orbit, the program would crash.
Crash hard.
13 got way better, right? 16's even better, but
18's even better.
please save before you do a 3D orbit. Just trust me, I've experienced a lot of pain with that. Unfortunately, Civil 3D is a 3D modeling software, but doing 3D orbits is not its strength.
The one
Just be
benefit of
aware.
doing that is if you get those arbitrary points that are like 0, 0, 0, you can't really tell sometimes just by looking at the plan view.
So the other thing that you should do, in addition to doing a 3D orbit of your surface and kind of looking at if you have any spikes or dips, is also to go to your surface properties under the analysis tab, the last tab, not analysis, statistics. It will show you some information on your surface. One of the most helpful things is it will show you the maximum elevation and the minimum elevation. And you can actually change in the definition too to ignore any values less than 1. AKA if you have something on 0, you can eliminate it without having to do an edit. You can just tell it to do that in the surface.
Okay. Notice I'm naming my outer boundary. Just call it out, but you can get more descriptive with it. And then what will happen is and this driver has to zoom in and out in order to happen. So I'm just using that data. You can see that it went real quickly. Okay. And what he's talking about is actually tilt up and look at your data in 3 dimensions and see. You can highlight over it and have it actually show you what the elevations are, and hopefully it comes up. Anyways, this is down at 0, and this is elevations that are really close to 0 because we're near the ocean. So you can see that described in here is a nice curb and gutter line, okay? You can see in here also, right here is a driveway. Here's another driveway. Here's another driveway, okay? But you may want to change the triangulation on that driveway just to make it look better, okay? Now that editing is what's something that you would look at in just swapping triangles. So if I went to modify surface, edit surface, swap triangle edge, and then I can swap that triangle edge and have it better represent the driveway, okay? Or I can add a break line that helps do that as well.
Mark, go ahead and swap an edge, just show them what happens when you select a line.
So
instead of going between these 2 points, it just changes the point that it triangulates to.
and it'll tell you if it can't swap an edge. And it's usually because you've swapped an edge before that and it's no longer able to swap an edge, or in fact, there isn't a point in which to swap it. Okay, it doesn't create something that has, the ability to do that. Okay, so again, this is a tool. It's just a matter on how you use it. Okay? So if I were to add survey information, how would I do this?
You have points.
Right? So if I had a bunch of survey information, okay, I'd add the points. How would I make the surface for those points?
You would import them into the surface, into the perspective,
Okay,
into the definition of the surface.
right, but if I do that, you're going to corrupt this surface.
Create a composite surface.
Okay, what I would prefer that you do is create a surface just from the survey points. You should have enough definition in your survey points to create the surface just from the
Well, what
points.
if there's 100 points here and 100 there?
Then you create two different surfaces.
Okay.
Or
Okay,
you create one surface and draw a boundary.
Right, okay.
okay, and so again, let's say I have a good density of data from this line to this line. What I'll do is I'll subtract out of this surface and cut out the aerial data, and then I'll cut in the survey data, okay?
At some point, you're going to piece that.
You paste it in, but the margin that you use depends on how close your data is, okay?
Yeah.
I'll say, so if your data is not that close, you might want a little larger margin so that it blends better, okay? Rather than just show a vertical edge of, half a foot, okay? So
So leave like a gap. Leave like
Leave-
a 3-foot gap between
3,
your
4,
survey
5
point
feet, depending on
and
how
your topo.
big the elevation change actually is, okay? So again, that's based on how much survey data you actually have. So if you have a good concentration of data here at this intersection, and your whole job is all about just this intersection, then just supplement the information in that intersection, okay? You don't need to supplement everything, okay? Let's say that you're just had to supplement here and supplement here because you're doing two center islands, okay? You supplement just for those islands. You don't have to supplement the whole thing, okay? But our preference is that you cut and paste the stuff in rather than try and supplement this information. Because what happens is you get elevations different by 6 inches and they triangulate to it, and you have these vertical surfaces that show up in your street. When you profile it, you have a profile that does that, okay? So again, keep that in mind. So when we're talking about composite surface, and we were going to get into that, but I ran out of time, technical difficulties being what they are, what you can do is in surface, edit surface, there's something called paste surface, okay? In pasting a more accurate surface into a less accurate surface, which order should you paste?
All right, since I have to think about it.
Okay?
The more accurate into the, no,
The less
Yeah.
accurate into the more accurate. Okay? Think about it for a while and then you understand why I say that.
if you're making a composite surface there at that junction, you want to add that into the existing survey if it's new design.
I understand that, but you want the more accurate data to be your base data. You don't want it
Well, it would
altering.
It would be if it came as a
No,
composite
because it
surface.
alters the second surface to match the first.
Okay, that's the golden rule.
Yes. So keep that in mind.
Matches the second to
Surface
the first,
to the first.
the bottom.
So the edges of your second surface may change. Okay?
Yeah.
So keep that in mind.
So something that I've found helpful too in doing kind of this comparison of aerial topography versus surface or survey data is I'll actually create a volume surface between the two existing surfaces to see what kind of air I have between the two. So you may want to do that on some of these larger, more complex jobs of, hey, you have a surface developed for your aerial, you have a surface developed for your survey. Hey, anytime you have two surfaces, you can create a volume surface between those two surfaces. You basically can come up with, hey, I've got, let's say, half a foot between these two surfaces. Well, then that's a pretty clear indication of, hey, I really shouldn't be using this aerial for much design work, right? So doing that quick comparison or volume surface can give you an idea of the level of accuracy of your data. Because that's what this is all about, is making sure that your data is accurate and correct.
Okay, the other thing that I want to point out is never get rid of the surfaces. Please keep them all. Even the ones you paste to create new surfaces. Keep them all. Never archive the C3 file, ever. Hopefully I stressed that enough.
Any questions?
I'm scared, yeah.
Nobody's scared of me.
No questions?
The PowerPoint that you have.
Sure. So all this data will be posted on our, where we keep all these lunch and learns and
We also
trainings.
had a handout.
So I will send out an office-wide email with that link. These are also all posted on YouTube. In case you guys did not know that, all lunch and learns are posted on YouTube, so you can access them at home on your free time because you have nothing
You
better
can
to
listen
do.
to our beautiful voices then.
Thank you.
All right, thank you guys. civil engineer, and of course this is Mark Webb. He did the last two lunch and learns while I was on medical leave. So it's good to be back with you all. So today's class is Surfaces 101. A lot of it is going to be kind of the definitions and terms behind it, what type of data and accuracy we have and what that should be used for, and then we'll try to get into a little bit of AutoCAD, but we won't obviously cover everything inside AutoCAD. So today's agenda: quick introduction to ourselves and what the class is, data types and accuracy, terminology that we use in both just civil engineering terms as well as AutoCAD terminology. What is the surface used for in Civil 3D? Our naming guidelines and conventions here at NV5, data shortcuts and why we use them, how to build a surface inside AutoCAD Civil 3D, and composite surfaces. So hopefully you all saw Carmen's email this morning. The gist of that is over the past 3 years, we've paid out $100,000 to clients due to mistakes by our staff. These mistakes basically stem from using the wrong data for the wrong application, something that we hope to fix today. So I'd rather have that $100,000 going towards bonuses. I don't know about you guys. So the more we can do to eliminate errors and omissions and mistakes, the better. No one in this room is immune to mistakes, right? We all make them. It's some more than others, but it's how quickly we catch those mistakes and what we do about those mistakes. All right, so as engineers, civil engineers in particular, we have several opportunities to catch mistakes, right? The first being QA/QC, right? Hopefully we can get a lot of mistakes sorted through that stage. And kind of our second line of defense is our surveyors, our field guys, right? They take our design, go out in the field, and they can notice some things, right? Hey, this doesn't quite look right out in the field. You may want to come and revisit that, massage some numbers around. So we've got a couple different ways of catching mistakes, but ultimately we want to catch them in design as soon as possible. And one of our earliest steps to that is the development of our surface ticks. All right, data types and accuracy. So in terms of existing surface TINs, this is kind of the rundown. At the very top of this list, we have aerial data. This is data collected from a traditional aerial, a plane flies over the site at thousands of feet up, takes a photo, looks through a special equipment called a stereograph, and the aerialist develops contours, break lines, and assigns elevations to the photograph, basically. And we get that digital AutoCAD file with that data. Typically, the accuracy of the data is half of the contour interval. So if we have a 1 foot contour map, our margin of error, half a foot, plus or minus half a foot, right? So what kind of design efforts should utilize this data?
Feasibility studies.
Feasibility studies, right?
Mass grading, feasibility studies, hydrology.
So this is kind of the typical data that we base all of our design off of for most of our projects, right? So we want to be careful where we use this data. We don't want to assign elevation callouts to anything using this aerial topography data, right? With 6 inches plus or minus, we don't want to be on the hook for assigning hard set elevations. The next group of data is GPS survey data. That is data that we collect from our surveyors and utilize in AutoCAD. The accuracy is plus or minus. It can vary considerably depending on the day, atmospheric conditions, cloud cover, number of satellites connected to the GPS unit. Typically we see about 1500ths, so almost 2 inches of variance in error. So this type of data you kind of want to use marginally, right? It's better than the aerial data, but not quite good enough for design efforts.
A lot of this type of data is also used in GIS applications.
Next grouping is Lidar. We've got a couple different Lidar approaches and methodologies. The first being a drone-based Lidar system, which is kind of the new technology that we have here at NV5. Hopefully you've all seen the drone up and out flying. I know there was a Facebook video of it. With the drone-based We're talking about plus or minus a tenth in terms of the elevation and contour data that we can derive. Most of that is coming from a point cloud, which we're not going to cover in this class. It's much more detailed and technical. The second method is a land-based LiDAR unit. Depending on the application, we can be pretty accurate. You can almost see there down to 3/1000ths of a foot accuracy in small, detailed areas.
But you have to tell them to do that. Okay? They're not going to do it out of the goodness of their heart. The other thing is the accuracy of the level loop on which they set this also controls the accuracy of the LiDAR. Okay? In other words, if they are setting this on control that's done with GPS, then your accuracy is now GPS accuracy. Okay? Keep that in mind.
And then we get down to the most accurate method, which is our traditional survey collected via a total station, right? Everybody familiar with that technology? When I mentioned, hey, get to 5/100ths of a foot accuracy, Joel up here in the first section was, no, we're way closer than that. So typically, if we've got a good level circuit, we can get within 2/100ths of a foot accuracy level. So we're pretty much, that's the data that we're after for our design efforts. Anytime we're assigning an elevation call out to data, that's the type of data we want to use.
The largest I've seen here is 3/100ths.
So on a typical project, what type of data are you guys using? What kind of survey data do you get?
Total station.
Total station? Are you sure?
Are you 100% positive in that?
All of our as-built survey must be as-built quality.
Okay. Check the source of your data. How would you know whether or not it's GPS or total station? Where would you go to find that?
Where would you go to find it?
Survey data, cover sheet.
The survey data cover sheet, which is located where?
Surveying office data.
Field data.
Field data.
Field data. So check those cover notes, check the field survey notes, know what your data is. You are only as good as the data that you put into the system, right? If you're using GPS data and you think it's this level of accuracy, you're introducing a lot of error and a lot of mistake and omissions into your plan design. So you need to know where your data is coming from and how accurate it is.
And the level circuit is always in the surveyor's notes, and they always make a copy of it.
Yes, Bryce?
So just because we're checking, but isn't that like the designers are telling the servers what to use just because we know we need a certain accuracy?
Sometimes.
Does that ever happen? I know
Yeah.
I've never told
Yeah.
the servers.
If you're going through our traditional channels of filling out a QQTR, you can specify what type of instrumentation
There's actually
you
a
want to use.
checkbox to check which one you want.
If you're not really assigning design values for elevation of retaining walls, street and curves, and you're just after topography, hey, GPS or even aerial is good, right? But if you start towards design of hard set elevations, you need to be down in this range, right? So depending on your design application and intent, yes, you can specify and tell the surveyors what type of data collecting method you need. And that can vary on your job. Not all your job has to be collected this way. You know, a lot of times aerial data is good for the majority of your job, and then you need this type of level in certain smaller areas where you're doing more intricate design. All right.
That's something you want to make sure you tell those surveyors at the beginning of your project, especially like you said, as-built data or hardscape. Don't use GPS, period. And that should be up to them to make the method of what they choose for accuracy.
The more coordination you can do with the surveyor, the better, right?
Have a dialogue.
As much as we're separate groups, we're still the same company. We should still have the relationship with one another. We have a lot to learn from them, and they have a lot to learn from us. The better we understand each other's workflow, the better our product is going to be. If they understand the type of work that you need the data for, they can then give you enough accuracy and data for that application. You know, just simply saying, hey, collect the street scene on a roadway, that's not necessarily enough information to your surveyor. First, if you say, hey, you know, I'm really doing a street rehabilitation project, you know, I'd really appreciate it if you could shorten up the cross section survey shots instead of every 25 feet. Hey, do every 15 feet down the road. Give me a cross section. That's what I kind of need on this project. It's
because
really
it's flat.
I need to make sure that the elevations are true and I'm tying in and it can really feather in everything.
Okay.
So be in communication with your surveyors.
Another form of information is as-built. Okay. Now, keep in mind that even in the city of San Diego, there's 3 different datums. Okay. There is on M12 the 3 different datums that the city has used over time. Currently, it's mean sea level, and they just started using NAV 88. Okay. However, a lot of their data from as-built is old city staff, which is off by about 6.3 feet. Okay. Keep that in mind. The easiest way to use as-built data is to actually take the difference between your surface shot and base elevation shot, say of a manhole, okay? Use that difference and use the rim elevation that you have from survey, okay? And use it that way. Never, and I'm going to repeat never, just take the information blindly from the elevation and then plop it onto your drawing, because you don't know that it's going to be the same. Okay. There's different vertical shifts as well as horizontal shifts. We haven't gotten into a lot of the horizontal shifts lately, but there is a horizontal shift that everybody should be aware of. Google is what? WGS 84, and it's different than NAD 88, okay, or NAB 83, okay. So the NAD 83 is a horizontal datum. NAV 88 is a vertical datum that uses the horizontal datum of NAV 83, or I'm saying that wrong, NAD 83. So be aware that there is some shift, okay, that you can't just blindly take the data. You have to know where the data comes from. Also, when we're dealing with stuff near the ocean, a lot of times we're dealing with mean lower low or mean low tide. How many people know what that term comes from? Anybody? What's mean lower low mean? It's tide.
Lower than low tide.
No, it's the mean lower low tide. Why is there a lower low? Anybody?
Isn't that 19-year cycle?
No, it's a diurnal cycle that actually goes, here's the high point, so it's a mean higher high and a mean lower low, then it comes back up and is not as high, so it's mean high tide, and then a mean low tide, okay? So there's actually 2 lows in the cycle and 2 highs. So there's a mean higher high tide and a mean high tide, a mean low tide, and a mean lower low. The port for years used mean lower low that was fixed. Mean lower low changes every year. Okay? Did you know that? Changes every single year. Okay? So a lot of people thought that it was nice and fixed. It's not. Port elevation was fixed, mean lower low, for whatever year they took it at, okay? Mean sea level at 1929 is what we affectionately call NAV 29, okay? When you hear that term, it's basically the 1929 survey. The NAV 88 is a more recent survey, and I'm not going to get into the differences in the geoids and all that other stuff. That's for a different time. But essentially, you need to know where your as-built data is coming from, okay? In Chula Vista, on one side of the street is 2007 geoid, and the other side of the street is 2010 geoid, okay? You have to know that. So, next topic is terms. When everybody talks about a surface, they talk about an irregular network, Okay? So that's what tin actually stands for. That's a picture of a tin. Then we have a digital terrain model. Digital terrain model can be a tin or a digital elevation model, or a DEM. This is a picture of a DEM. They're the same surface, but one implies more accuracy. Okay? We don't use the DEMs for that reason, because a lot of times they apply an accuracy that isn't actually there. Okay? A lot of times it's also based on elevations that are spaced out 10 meters apart, and so the density of the data is not there. Okay? So a DEM is based on a grid. The grid sometimes is, most of the time is square, but does not have to be square. Okay? And with that, we have a lot more terms.
All right, so some more terms. We talked about aerial photogrammetry. As a typical example is that from the EXTO files that we received from inland aerial. That's a fixed wing airplane from 1,000 to 2,000 feet up, taking a photo of the site. Lidar and drone. Anybody know what a Lidar unit is? What kind of technology it uses? What's the principles behind it? Anybody? Diode, laser. It uses a laser pulse, and it measures the response time of a reflection back through a sensor. So that's what a Lidar does. Orthophoto. This is an emerging technology as the technology for cameras become better. We're going to see more and more of this. This is basically elevations developed from just a photograph, all relative to itself. So this is where the technology is really proving very useful. Currently, the technology is about 2/10 accuracy from just a photograph. No survey control. Survey database, that is the Civil 3D database that we use to manage all of our survey data, being survey points collected through GPS and total stations, and survey figures, which is the automated line work associated with the survey points. Inside AutoCAD, we've got a couple terminologies that I want to discuss. So when we create a surface, which Mark will get into later, just wanted to review the terminology. Boundary is obviously the outer limits of your surface. It's a polyline that you create to then limit the amount of triangulation and area covered by your surface. The next is break lines. Break lines are either 3D polylines, feature lines, or survey figures that you want to add to your surface. Basically, what it does to the surface is no triangulation can go through that break line. Very useful definition. Contours, those are basically elevated polylines that you add to your surface that are set on certain contour elevations. DEM files, we don't really use. Like Mark said, those are digital elevation models. We don't really use those for our surfaces. Drawing objects are kind of miscellaneous things that you want to use and add to your surface. If we right click on this and go to add, we can see what types of things we can add. You'll notice that there's more than just points. It's points, lines, blocks, text, 3D faces, and polyface. Two most common ones that we will use are points, although the preferred method is point groups. And then probably the most useful thing out of this drawing objects is the blocks. So from inland aerial, we'll typically get these little X's, right, that are spot elevations. That X is a block on the elevation, right, that the aerial is set it at. We want to add those blocks to our surface to get the most definition. So this is where we would add it. We'd add it as drawing object block.
And I'll show you how to do that in just a little bit.
Edits, this is the location where every edit that you make to the surface will show up. Ideally, a clean surface would have as few edits as possible, and there's methods to kind of clean that up. Typically, what we want to do is we want to look at deleting points, eliminating triangles, swap edges, and whatnot, and then we can generate a boundary. And then once we add that boundary, we no longer need all those deletions because we have a boundary. So we can just add a boundary and kill all those edits, all right? When I see hundreds of edits in a surface file, I get rather nervous. That means somebody thinks that the data wasn't good with to begin with, right? If it needed to be edited hundreds of times, makes me very nervous. I don't know if I want to use this, right? So a clean surface should have very few edits.
Usually only 4, and those are the 4 automated ones that are come with
When you create a surface,
when you create a surface.
they'll show you can swap edges, minimize flat areas, and 2 other ones. And then add a boundary and add point groups. That's usually what you'll find under edits. Shouldn't see a whole lot of delete lines and delete points. Point files, we don't really use that because the preferred method of adding point data is via point groups.
Why do we do that? Why do we use a point group?
You could include and unclude points easily.
Yeah, but it's also a good way to know which points you used in the surface.
If you just add point files or points through drawing objects, there's no way to really know what points are being utilized by the surface. Versus a point group, you can always go back to your point groups and see exactly what's included, what's excluded, and what points are being utilized. Very important when you create a point group and you intend to use it for your surface, that you exclude what type of points. So yeah, that's a good one. Any checkpoint, sometime monuments, right? Because they'll shoot a monument a mile, half a mile away. You don't necessarily want that to be part of your surface group.
Or the monument is in a monument well and 3 to 4 inches below your surface.
Up or down and frequently not flush with the surface.
Correct. Any dips, right? We send our surveyors out to get a lot of dip information for existing sewer, storm drain manholes. Any dip information we obviously do not want to include. So we need to exclude that as part of the surface 10 point group. Paint marks are actually very useful to use. I would actually recommend using paint marks on your initial surface because those are pretty accurate, right? They're usually found on pavement, which is a pretty easy surface to survey. So I would actually say include paint marks.
The only thing about that is sometimes they're getting it in traffic areas and they're shooting it quickly so they don't get killed. So the accuracy isn't always that good.
And especially keep that in mind if they're using GPS, right? The big thing with GPS is you need to cook the point a little bit, all right? You're getting signal from satellites, right? So you need a little bit of time for all that triangulation to happen, which means the surveyors have to cook the point for typically, 10 seconds? 3 seconds. So on a busy intersection, they don't want to be there any longer than they need to. So they're going to click the button and run, right? So again, be aware of where your data is coming from, what collection method is being used, and what kind of accuracy you have introduced into your surface.
I had a question about point groups.
Yes.
I know it's not the right way, but so you have import events and they create point groups and you can use that. Do you suggest using a surface point group?
Most definitely.
You're going to get to that? Or no?
No, that's a very good point. And actually, you'll notice that there's not one in the template. I will probably add one to the template. That was kind of an oversight on my end, quite frankly, to kind of pre-exclude some inverts. The one thing you have to be careful about is flow lines, because sometimes flow lines is the flow line of a gutter, which you'd want to include, but sometimes they also do flow lines for dips. So some of the point group excludes. You need to actually look at your survey data and see exactly what it is. There's multiple different ways of excluding things from your point group. You can do the point itself by selecting the point, entering the number of the point, and also entering the description of the point. So in certain cases, you're going to want to pick points to eliminate. You may want to not exclude all flow lines, but there may be some dips that are coded as flow lines that you need to exclude. So just kind of be aware of that. The last two on here, point survey queries. We don't really want to use that. I've never used that in my career. Again, we want to use point groups so we know exactly what we're using. Same thing with figure survey queries. You should know what what survey figures you want to use as break lines. Those are the only ones that you should import into this drawing, is just the ones that you want to use. So you can do that through your survey database. You can select what survey figures you want to import.
You also know that if you change the point group later, it also edits the surface. Okay? So that's why we're suggesting you make a separate point group and you keep it as is. If you edit that point group, you've edited the surface.
Which is helpful because it's then dynamic. So you don't have to recreate this thing. It's just, hey, rebuild and you're good.
When you're first building it. But later in the job, you're not wanting to change that existing surface.
All right, so we talked about surface tens. What are surface tens used for? That's a question.
That's a question.
Question mark? What are surface tens used for?
Contours.
Contours? What else?
Spit it out. Let's go.
Spot elevations.
Spot elevations, surface profiles, right? What else?
You use that to calculate your cut and fill.
Volume surfaces, generating quantities, earthwork quantities. Just about everything, right? Everything we do in Civil 3D utilizes this surface, right? Whether it's an existing or proposed, usually everything is based off of these surfaces. So we talked about what the existing grade looks like over a proposed trench or alignment. How about pipe networks? How do pipe networks utilize surfaces?
Coming from a surface point down or up, I guess.
So when you guys are creating pipe networks, the pipe network has to be tied to your surface, right? And then what the software does is every pipe network uses a set of rules to then set the pipes, right? So let's say our typical water lines, right? If we go into the EXWT pipe network, you'll notice you'll set it to the surface, right? And then when you create a pipe, it's going to use a cover rule to then draw and set the elevations of your pipe. So what that cover rule is typically 3 feet. So every pipe that you draw is going to take the surface, go down 3 feet, and that's your top of pipe. So when you're creating pipes, it uses those rules, which are tied to your surface. So basically everything in Civil 3D uses this surface, so we need to be sure we know what is part of our surface definition, how accurate it is, and what kind of data we're representing. Naming conventions. All right, so some of this is old, some of it's new. File names have not changed. EXTO, right? That's our baseline work for topography, both contours and planimetrics, right? If our aerialist picks up the face of the curbing, sidewalk, trees, all that stuff is in the EXTO. EXTO C3 is basically the extraction of all the elevated data, and this is the location that we then build our surface 10 in. Reason why we want to keep these different is a Civil 3D object tends to bloat the file size, right? Because now you actually have a 3D model inside your file. So it's going to be a much heavier file, a lot slower file. The EXTO, we're XREFing into every single drawing or plan sheet. We don't want it to have this large 3D model that we're then XREFing into every sheet. It's going to slow down our computers, slow down our process. So that's why we have the difference between regular and the C3 file. We have the same thing for proposed topography, PRTO, PRTO C3. New convention here, surface names. We need to be a little bit more accurate and descriptive of what we're creating our surfaces from. So instead of calling it EG, which was kind of the old NOLT NV5 convention, we kind of progressed to EXTO. That's kind of where we are now, right? We call all of our existing surfaces EXTO. Well, we need to define it a little bit better. We want to track where this data is coming from. So this is the new naming convention, EX-aerial, if the source data is from the aerialist. EX Lidar, if it came from Lidar data. EX Survey, if it came from conventional survey collected via GPS or the total station. EX Comp, that's for a composite surface that Mark will get into a little bit later. It's where we're pasting surfaces together to form one surface from several types of data. And then we also have proposed surfaces, right? So instead of just PRTO, we're going to have PR and then what it is, all right? So let's say this proposed surface was created from a corridor. So let's call it PR corridor road A, or whatever you're naming your corridor.
Please be descriptive with the name so that, you know, it's not just corridor 1, corridor 2, corridor 3, corridor 4. How about just name it as road A or road B or whatever it actually is?
And then in your base file, your PRPN, you should have that street name there. Road A, road B, road C. A lot of times, especially in land development, when we start projects, you don't have street names yet. So you're forced to go A, B, C, D all the way through. And so that's important to know what road is assigned which name, even if it's a letter description. Next thing, the first thing you see in the Create Surface tab, obviously you give it a name, and then you have this big empty box for a description. We need to be descriptive in that. So the two requirements are the date that the surface was created or modified and your name. You can put your initials, that's fine, but we need to take ownership of the things that we create. We do good work here. You should be proud of your work, put your name to it.
Never change the creation date for modification.
Give as much data.
Add the modification data to the data that's already there.
Or a brief description of why it was modified, right? Say, hey, new contour data or additional survey data. But we need to be able to trace our workflows and the modifications and revisions and why they happen. So let's be a little bit more descriptive in some of our descriptions. It's built into the software. The developers were insightful enough to see that, so let's utilize it. So in addition to just surface tins, we can create volume surfaces as well. There are basically two main methodologies of creating volume surfaces: grid surfaces and 10 surfaces. 99% of the time here we will be using 10 volume surfaces. I'm not going to go into details, but just know that. And that's kind of the convention. Feature lines. Where do feature lines go when you create them? Where do they appear in your Prospector tab?
Survey database.
Nope. Sites, right? Feature lines get put into sites. How many people name their sites? No one, right?
Site 1, Site 2, Site 3, Site 4.
I can't tell you how many files I've opened and seen Site 1 through Site 10. And then I need to figure out where are these sites? Why were they created? And then I look at feature lines, and there's just a bunch of empty named feature lines, right? So I've literally got to pick on each one, zoom to, figure out what it is, and good luck, right? So let's fix that. Name our sites, right? Tell me what it is. Is this the site for existing aerial feature lines? Is this the site for proposed feature lines? Give some indication of what the site is for. In addition to that, we really need to name our feature lines. Every feature line that we create inside AutoCAD should be named. Whether or not it's TC, flow line, top of wall, whatever it is, give it a description as part of the name. Now what you can see is obviously, hey, I'm going to create more than one feature line for TC, right? So do I go TC1, TC2, TC3? No. Give it some direction in terms of orientation to where you are in the plan. Is this TC west side of A Street? Name it such, so that anybody looking at the name knows exactly where this is drawn in plan. I can't tell you the headaches that this causes, especially on proposed grading.
So, you know, we use data shortcuts, and you know the way we use the data shortcut is to actually make the EXTO version of the file smaller. So in the C3 file, you have the actual surface built, okay? You have the data there. You have the three-dimensional model. You create a data shortcut and then can use that data anywhere in your creation of future files. We have something called a no display. You can import that, have it no display, and just have the data there that you can use, okay? Now, it keeps the file size down, keeps them quick. It's easier to reference in EXTO, which may be 2 megs, rather than EXTOC3, which is 15 megs, okay? It's going to speed up your drawing process, speed up your sheet files, okay? So when you're making PDFs and you're trying to get them to Doug by 3 p.m., you can actually do it as opposed to waiting for it to regen. So it also, you know, you're using that surface everywhere. You're using it to cut profiles. You're using it to generate, you know, pipe networks, okay? So you're using it in other C3 files, okay? You're using it in the PRTL. You're using it in the PFTL, okay, for those for the power group. You're using it in a PRTO for grading. You're using it in, you know, just road centerline profiles, okay? So that shortcut gets used. What happens if you archive this drawing? All the data shortcuts go, okay? They go kaput, and they error out. You can put the thing back, but there's still, all the data shortcuts are gone, okay? So the second you move that file, boom, they all go dead, okay? So keep that in mind. And then we're going to go and show you a couple of things in AutoCAD, so give me a second.
Are there any questions while Mark sets up his AutoCAD drawing? Yes, Amy.
I just have a comment.
No, I said questions.
For everyone to know that I get asked a lot for, oh, can you get me contours for an extra area or something, or tiny topo for this? And I always try to emphasize it, but I know I'm not the only one creating stuff from GIS, that the GIS topo that we have available doesn't fall into any of those categories. It should never be used for design.
Yes, that is
And I
only
feel
like,
not everyone understands that.
that is like a hydrology level of this is the direction water flows type of thing. Be very careful about GIS contours. Back in the day, you used to be able, you still can, there's workarounds, but you can develop surface tins from Google Earth. If you'll notice when you bring in Google Earth imagery or Bing Map imagery,
Big old disclaimer.
the first thing you notice if you have like an EXTO file that you're bringing it in, does it line up? No, never, right? So if horizontally it's not lining up, what do you think is happening vertically? It's not lining up with real world conditions, right? So be very cautious and mindful of your data sources. That's kind of the whole point of today's Lunch and Learn, is to know where your data is coming from, the type of accuracy associated with it, and the appropriate way of using that data. The last thing we want to do is be designing, you know, join conditions on streets based off of data that's plus or minus 6 inches, right? You can see how we can rack up $100,000 worth of errors and mistakes by using that data. So that's kind of where some of those projects Carmen mentioned, that's what kind of happened, was we were using this top tier, low accuracy data to design finite, intricate design work. You can see where the conflict is.
A lot of times it seems like, you know, we have a design and something changes and we need an extra area. So we maybe have really good, you know, survey data, and then someone says, oh, I need some topo in this area, which I would give them like, you know, USGS 30 meter DEM or 10 meter DEM, whatever is best available. And you create a surface, like, you can't finish the design using that. Like, you have to then have survey go out and finish.
So that'll be part of Mark's workflow here when he goes and builds a surface of, you know,
Right.
starting with the aerialist, and then what do we do when we get survey data, what type of survey data it is, and be in contact and communication with your surveyors. You know, if you need better data, more accurate data in a certain intersection, or where you're doing a handicap ramp, or, you know, some critical data, hey, communicate that to your surveyor. Make sure they understand what you're doing so that they can give you the data that you need and to the level of accuracy that you need.
So one of the first things that you need to do is start a new drawing, but start it with a template, okay?
How many people take the file we receive from Inland and run with it? that becomes a simple rename as EXTO.
And everybody in here that creates surfaces should raise their hand.
Raise their hand. I see it all day long.
We see it almost every single day.
I can't tell you the number of errors that stem from this. Your guys' life will be made so much easier if you follow this protocol. Anytime you receive a file from outside this office, open a new drawing from our appropriate template and insert that drawing in. Why do we want to do that?
Because if they have a pre-civil 3D, it comes in international fee.
All right, that's a good answer.
That's one answer.
What's the difference between an international foot and U.S. survey foot? Why is that important?
Depends on how many millions of feet you go.
Right? The difference. Anybody know the difference between a U.S. survey foot and international foot?
It's
Beside Nick.
It's almost negligible in a foot, but our coordinates are 2 million, 6 million, and it ends up being 15 feet different.
Correct. That's a big deal when you go out into the world and stake things. So that's one reason. Drawing settings, making sure you're in a coordinate system, the right zone. What else?
Layers.
Layers.
There's all kinds of crap that you could bring into
Crap.
that drawing.
Beautifully incorporated things.
From the outside source.
That some
it
genius
might be
put in there.
crap.
Correct. There's a lot of crap. There's a lot of crap in the file that you received, right? So one example of that. There are hundreds of AutoCAD variables stored in each individual file. So the other day I had a user say, hey, I go and draw a dimension, and the minute I draw that dimension, it's all exploded. Why is that? Well, that's a variable associated with the file. Well, that file, you bet, was not started inside this office. So there's thousands of variables and settings that are stored locally in each individual style.
Layers.
So more than just layers, Civil 3D styles, naming conventions, Civil 3D object layers. There's AutoCAD variables as well. So it really controls your AutoCAD experience.
Then pick the DTM file, okay, and actually explode it as you insert it, because when it inserts it, it's going to be a block. You want it to be inserted as individual entities. It will not explode interior blocks to that drawing. It'll just explode the initial block of setting it in here as a block, okay?
Just be aware that next time you go to insert a block, that
check mark's going to be checked.
So be sure to uncheck that if you don't intend to explode your block.
Okay.
And most of the blocks that I've developed here, you cannot explode, just so you know.
So when you insert the DTM file.
So you just said, once we get this inland aerial, are we going to get away from separating an EXPN and an EXTO? Are we going to leave everything, and the EXTO is going to have planometrics and?
We're not trying to change your workflow. All we're trying to do is make sure that we know where the data is coming from, okay? So essentially, if you separate out an EXPN and an EXTO to be just contours, then that's part of your workflow, and that stays the same. But that's the root file. It's not the C3 file, okay? So in the C3 file, leave them together, okay? Because you're not going to make a C3 file of the EXPN, okay? You're only going to make a C3 file of the EXTO. So leave them together in the EXTO C3 file, okay? This has way too much data for what I'm doing, so I'm doing something that other people shouldn't. So I'm going to select a whole bunch of data. Haha, got too much. Select that.
If you guys didn't see that, that's what happens when you hold down the click and start dragging for a window. You'll get a lasso.
If you have lasso.
If you have a lasso on.
I learned something.
So that's essentially, you know, how you. I trimmed down the data because I didn't need it all just for this explanation, and it'll run a whole lot faster without it. So again, I create a surface, and from the last one I created an EX1. So in this one I'll create.
What do you think?
What do you think? No.
Suspend his license, right?
Preach what you teach.
rough crowd.
Explain what we're looking at right now.
So what you're looking at is the tool space. The tool space has several different tabs on the right-hand side of the tool space. The first one on the top being Prospector. This basically lists all active Civil 3D objects inside your drawing, be it points, sites, surfaces, grading objects, points, survey figures, corridors, all kinds of different things. So this is one way of, inside Civil 3D, there's always like 4 ways of creating or doing something. You can always create an object from the Prospector. You can always
I
create it
right-clicked
from
on the
menu.
Prospector.
So it's just a way of organizing all the Civil 3D objects inside your drawing. The next tab down you'll see is Settings. That's where you would want to go to change and edit your drawing settings, such as your coordinate zone. So by default, the template has it as California Zone 6, US survey feet, right? So if you're doing work a little
Further
north
north.
of us, you might be in Zone 5. So if you are doing work in a different zone, you need to change your coordinate zone to reflect that, right? It's one of the blessings and curses of having it preset to Zone 6 is that a lot of times we neglect to check that. So if your project is in a different zone, be sure to do that. That is through the Settings tab. The other thing available in the settings is all your Civil 3D styles. Basically, you don't really have any reason to go in there and edit them. Hopefully the template has enough styles for you where you don't have to edit styles, but that's where you would. And then kind of the third tab down is the Survey tab, which is the location of your survey database. This is where all your survey points and survey figures are stored. When you access this, you should open that survey database as read-only, right?
Well,
In 99% of the circumstances, your survey guys should be adding import events to your survey database and doing their own QA, QC prior to it hitting your desk. So all that information should already be entered into your survey database. So open it as read-only so you're not changing things accidentally because it's not necessarily part of your workflow. So we don't want just anybody in there making global changes.
and one of the things that is a problem with the current CAD initiator, Cadillac, whatever we want to call it,
NV5 CAD Data Manager.
Yeah, NV5 CAD Data Manager, is it doesn't set this data correctly. Always check it, okay? So when it's not set to that, I go down here, it opens the last project I was in, okay? So that last one I actually went to a survey database, okay? Not the actual last project you were in, but the actual one where you actually opened a survey database. So in the Prospector, what you can do is set that if you want to. I'm not going to. But so in aerial data, definitions, break lines, okay, I can set those, but what's the best way to get them all? Quick select. I can actually pick from the entire drawing and pick 3-dimensional polys from a layer called topo break line. Okay?